Hi folks, in this video we're going to look at transformations of a quadratic function or a parabola, and this video is going to tie in a bunch of concepts that I've talked about individually in videos in the past, but this video is going to kind of summarize a lot of different things. Okay, so if you want more information on one specific thing that you see on here, I recommend just watching that actual video that's specific about that. Okay, so a transformation is basically, in the beginning, the initial parabola, I sometimes call this the mother of all parabolas, is just y equals x squared. And the reason why we know it's a parabola is because of this little 2 here, this little squared. And when we put that there, we automatically get, when we graph it, we automatically get this thing called a parabola. When you start changing, like putting this thing in a different form, for example, in this form up here at the top, whoops, let's see here. I'm just going to get rid of that. This up here, this is called vertex form right here. And the reason why it's in vertex form, the reason why this is nice is because all you do is you take this value of h right here, you take the opposite of it. That's going to be your x value of the vertex of a parabola, and the k value, that's just going to be the y value. Okay, so the x and the y value, this will tell us, if numbers are here, it'll tell us where the vertex is. And this value of a right here in the very front, that'll tell you how skinny or how wide or how stretched. Your teacher may use many different terms when you put a number right here with how that affects the parabola. So a stretched parabola might look skinnier like this, whereas a wider parabola might look more like this. Okay, depending on the value that is right here where the a is. Okay, so if we were to, let's see here, if we were to drag over what we see right here, and if we were asked, what is the vertex? Where is the vertex of this particular parabola? Well, it's in vertex form, so all you do is take the opposite of the number you see in brackets. Okay, if this said +3, then we would write down -3, but because there's a -3, we're going to write down a +3. Sometimes I say that the brackets always lie to us. So that's why we take the opposite of what you see right here, comma, and this number right here, this 4, well, you don't have to change the sign at all. You just write that. So we know this parabola would have a vertex of 3 across and 4 up. I'll just do a quick sketch. We know the parabola is opening upwards because this value right here is 2. It's positive. So we know the parabola is opening upwards. And the 2 talks about how wide or narrow or how stretched this parabola is. It's being stretched by a factor of 2 here. So it's twice the narrowness or twice the stretched factor that it used to be. Okay, we'll talk more about that later, but for now I just wanted to quickly give you this overview. Okay, here's a quick sketch of what we see right here, and see how quick that was? It's not terribly complicated once you get used to it. So with a little bit of thought, when you see something like this, we can determine the following things right here. Now the axis of symmetry, if we have a parabola, let's say we draw it right here, the axis of symmetry is this red line that you see right here. It cuts the parabola into 2 symmetrical halves. Okay, my line is not perfect here, but that is called the axis of symmetry, and it cuts through at one of these x numbers right here, like 1, 2, 3. This could be x equals 4 would be the axis of symmetry for this parabola that I just sketched right here. Okay, and the axis of symmetry is always going to be the exact, sorry, my phone is ringing. The axis of symmetry is going to be the exact number that the vertex is. So if the vertex here was 4 across and 3 up, like the one before, then it would be, the axis of symmetry would be 4. The number of zeros, well, with this particular parabola, the number of zeros is, there are no zeros, it doesn't cross. But we can think about all those things. We can see here that this would have no zeros though. If it's going 4 across and 3 up and it's opening upwards, there would be no zeros at all. The y-intercept, all you would do is set the x to 0. Okay, so you'd make x equal to 0 and multiply everything through, and you would have the y-intercept right over here. And a quick sketch of the graph, well, that's what I just did here. Okay, so with a little thought we could do that. And with a little more, with a little more work, and I have videos on how to do this, you could take this vertex form and you could rewrite this equation in standard form just by expanding. Okay? You could just expand it by multiplying what's in the brackets here. You'd multiply it by itself. Okay? And then you would multiply by whatever number is in front here. And then you would also add this k, and you would have an equation, a quadratic equation, that would be in standard form. Okay? And once you have it in standard form, then you could factor it, and you could find out the actual zeros. Not just how many there are, but you would know exactly where those zeros are. And you could either factor it or use the quadratic formula. And again, each one of these words that I'm saying that may sound confusing, I have videos for. Okay? Now let's talk more about these transformations of quadratic equations. So here we go. This is the typical kind of question you might get. State the vertex of this equation right here. Well, it's in vertex form, so it'll be very quick. So for A, the vertex would be, remember, it's the opposite of what you see in the brackets here. So it would be -2 and -4. So you take the opposite of what you see in the brackets and write it right there. And the -4 we just write right here. State the axis of symmetry. Okay, so for B, the axis of symmetry, remember what I said, it's just the very first x value right here, -2. State the direction in which the parabola opens. This parabola has a positive, there's actually nothing here, which means it's positive. So right after the equal sign, if there had been a negative here, kind of like this one, it would have been opening down, but because it's positive, it opens up. So the direction of opening is up. Sketch the relation. If we did a really quick little sketch of this, -2, -4, 1, 2, 1, 2, 3, 4. There's our vertex right there. It's opening up. And a sketch doesn't have to be precise, okay? This is just a simple sketch. And if you had to sketch this thing more precisely, then I would direct you to what you see right here. Watch the 135 step method video for how to sketch a parabola. I have a video on how to sketch a parabola using this method, and it's super quick and it's super easy. You start at the vertex and you look over at the equation right here, and if the value is just 1 here, which it is, it's just 1, you would go 1 over and 1 up, and you'd put a dot. Then you would, from that dot, you would go 1 over and 3 up. That's why it's called the 135. So you'd go 1 over, 1 up, 1 over and 3 up, 1, 2, 3, and put your next dot. And then from here, you would go 1 over again. And if you could guess, you would say, you're going to go 5 up from here. That's why it's called the 135 step method. So 1 over 1 up, 1 over 3 up, 1 over 5 up. And then you would have a precisely drawn parabola. And to mirror this, you would do the exact same thing on the other side, just to get it looking exactly like the other side, because parabolas should look symmetrical on each side. Okay, I have a whole video on that. It's actually really quite fun. So this one here, let's do the same thing. And if you want, you can push pause and try to answer these 4 questions based on what you see right here. I'm going to start answering them right now. So the vertex, remember to take the opposite of what you see in the brackets. It would be 3, and over here it would be -1. So there is our vertex. Axis of symmetry, x would equal the x value of your vertex. X would be 3. State the direction in which this parabola opens. It is negative here. Look at this negative in the very front. Do not look at this one here or this one. Look in the very front. It's opening down. Okay? Sketch this. Well, let's sketch it really quick here. 3 over to the right and 1 down will be our vertex. 1, 2, 3, and -1. There's our vertex. It's opening downwards. Okay. If we had to do this really well, we'd use the 135 step method. And yeah, I really shouldn't jump right into this, how to deal with this 1/2 right now, but I'll tell you just briefly in case you're interested. Instead of going 1, 3, 5, but downwards, here we went 1, 3, 5 upwards. You could go 1, 3, 5 downwards, but because there's a 1/2, you actually multiply by 1/2 each one of these, the 1, 3, and the 5. You multiply them each by 1/2. So it would be go 1 over and not 1 down, but half down. Then you would go 1 over, and instead of 3 down, you would go half of 3. So you'd go 1 over and 1.5, which is half of 3 down. Then you would go 1 over again and do half of 5. So instead of the 135 method, because of the 1/2, it would look more like the 0.5, 1.5, and 2.5 method because of that 1/2. So anyway, that's something that a whole video can explain, which I do have. Okay, in this video I'm worried that that's just going to confuse you, so don't let that bother you. Okay, in this example here it says sketch the new graph that results from applying these transformations to this original mother of all parabolas. So the mother of all parabolas was an original parabola, y equals x squared, that started right here. And remember, it goes 1 over and 1 up, 1 over and 3 up, 1, 2, 3, and 1 over and 5 up, which can't even appear on this graph. That would be the original parabola right there, the mother of all parabolas. I'll do it in blue. You don't always have to draw this. Your teacher may not want to see this one. I'm just drawing it just for fun. So it says translate this thing 3 units to the right. Okay, so we're going to translate it 3 units to the right. We're going to stretch it vertically by a factor of 2, and we're going to translate it up 1 unit. Okay, so let's start with what happens to the translation. So it's going to be, sorry, I think my family is doing exercises upstairs. That's the noise you might be hearing. If you want to stop and listen. Wow, they're really working hard up there. But anyway, let's translate this thing 3 units to the right, translate it 1 unit up, and then let's worry about this stretching it by a factor of 2. So we're going to take these points, transfer them 3 units to the right, 1, 2, 3, and up 1 unit. So the vertex is now going to be right here. Okay? Now it says we're going to stretch vertically by a factor of 2. So instead of the 1, 3, 5 method, we're going to stretch it by 2, which means multiply each one of these 1, 3, and 5. Multiply them each by 2. It's really going to be the 2, 6, 10 method. So we're going to go, it's opening upwards. So it's going to go 1 over and, instead of 1 up, it's going to go 1 over and 2 up. From here, it's going to go 1 over, instead of 3 up, it'll go 1 over and 6 up. 1, 2, 3, 4, 5, 6. And you would keep, mirror image. I know it's hard to see that because we're off the graph there. But see how the parabola is now skinnier? It's been stretched by a factor of 2. Okay? If we had to write this equation, and it's not asking for the equation. Oh, it is, right here. So here's the sketch and the equation. Okay, it's been stretched by 2. So you write the 2 there. It's opening upwards, so you keep it a positive 2. Then brackets, x. Now it's going to the right, 1, 2, 3. So you're going to put not plus 3 here. You're going to write x minus 3. Don't forget the squared. And then finally, it went up by 1. So plus 1. Okay, so this is going to be our equation. I hope you could hear me through all that exercising going on. Anyway, let's go to the next question. Here, list the transformations to this parabola right here. So let's list the things that are going on, starting with the very front. At the very beginning, we can see there's a negative sign. So you can say it is being flipped. Okay? I don't know how your teacher is going to want you to say that. It could say it is flipped about the x-axis, or you could say it is now upside down, or you could say the parabola is opening downwards. But as long as you say something to do with that negative sign, I think your teacher will be happy. Okay? So it is flipped upside down. It is opening downwards. Next, that 1/3 means that it is being, you could say stretched or compressed, but either way, it's being stretched by a factor of the exact number you see in front of the bracket. So 1/3. That's how you'd write that. That means it is wider than usual. The parabola is 1/3 what it normally would be. Okay, so it's going to be wider. Some teachers like you to say compressed. Okay, but stretched is also okay by some other teachers. The other thing is this 4 here. Well, the parabola is being shifted horizontally left 4. Okay, and I'm just writing the brief version of what I'm saying, it is being shifted left 4. Or you could say translated left 4. And the 2 on the end, that's a negative 2. That has to do with the vertical translation, okay? So it's being translated down 2. There we go. Okay. Push pause if you want and look at that while I move on, because we want to get through this video without it being too long. Determine the equation of the graph. So here's a situation where they give you the different clues about what's going on to this mother of all parabolas, and you're supposed to write the equation. So let's do that right here. Okay. Translated 4 units to the right, vertically stretched by a factor of 5, reflected in the x-axis, translated down 5 units. Let's start with the very beginning. It says reflected in the x-axis. That means it's flipped upside down. So I'm going to put a negative sign. Okay, so we're done that one. The next one I see here, it says vertically stretched by a factor of 5. Well, the stretching or compression is always the very first number that you see. And I'm going to put this in vertex form just like we've been doing all along because it's so useful. Okay? It's so useful for these situations. Translated 4 units to the right. Well, it's going to be x. Now to the right, normally we'd think, well, that's plus. But when you have this situation here, you have to remember the brackets always lie to us when it's in this quadratic form, this vertex form here. And you're going to write the little 2 there because the 2 tells us that this is a quadratic. So we can't forget that. It's very important. If you forget this, really all we have is a straight line. And we're talking parabolas here. Okay? And the last thing, it's translated down 5 units. So it's moving down 5 units. And this would be our equation right here. We have just come up with an equation. And if it said put the equation in standard form, then we would have to again, go x minus 4 multiplied by x minus 4. Okay, you would multiply all that out. And again, there's videos on how to do this. You should know that already because that's stuff that you learn way before this stuff. But if you forget, some teachers call this FOIL, first, outside, inside, last. They multiply it all out. Then you take your answer, multiply it by negative 5, and then take that answer and make sure you add the negative 5 onto your equation. Put like terms all together, and you will have, standard form. But I think most teachers would be happy with you just to stop right here and say, indeed, this is a quadratic equation. It didn't say what kind. This just happens to be the easiest and simplest one to use. Okay, I think we're on to the last question. Given the equation right here, what is the vertex? Well, we've been doing this for a while now, so you probably know. You can push pause if you like and fill in these questions. The vertex would be at the opposite of negative 4 is positive 4 and negative 1. The axis of symmetry is just the 4. Make sure you write x equals 4. And the transformations, well, it's moving right. This whole thing is moving right 4 and down 1. Okay? That's the transformation. It's being translated right 4 and down 1. There are no vertical stretches or compressions going on. There is also no negative sign here, so this parabola is opening upwards. So let's quickly graph it. 4, negative 1. 1, 2, 3, 4. There we go. We know it's opening upwards. All we have to do now is we could use that 1, 3, 5 method. So 1 over 1 up, 1 over and 3 up, 1, 2, 3. 1 over and 5 up, 1, 2, 3, 4. Oh, it would be right here. Do the mirror image of that right here, okay? Because the parabola has to have a mirror image. Whoops, sorry for my mess. And this would be our sketched parabola. It's quite satisfying to go to Desmos and just punch this into Desmos and see, and that's just an app you can get on your phone, it's free. You will see if you get this parabola, and it's quite satisfying when you get the exact same thing. You just did it in your head instead of Desmos needing to be your guide. Okay, was that the last question? Oh, this is just a quick one. Here's one more. And once again, just find the vertex first of all. So it would be the opposite of what you see in here. It would be negative 1 and negative 4. Negative 1, 1, 2, 3, 4. There's -1, -4. Now the 1, 3, 5 method is great, but when you have a 2 here, you have to double the 1, 3, 5 method. The 1, 3, and the 5 get doubled to become 2, 6, and 10. So you go 1 over and 2 up, 1 over from there, and 6 up. 1, 2, 3, 4, 5, 6. And then 1 over and 10 up, but there's no room here. So most teachers are happy if you just plot 5 points to make a parabola, you'll probably be okay. 1, 2, 3. Where's the other 2? Well, mirror image. Just do the mirror image. And then you're good to go. So this parabola is skinnier than usual. It's been stretched by a factor of 2. And some teachers like you to write the equation beside the parabola. In this case, it's right there. It's kind of obvious that that is the parabola that's being graphed. And hopefully your plotted points are nice and neat. And I believe that was the last question on this video. I hope that it gave you an idea. Boy, there's a lot of things about vertex form, which this is, about the zeros, about translating left or right, up or down, and also the also the vertical stretching or compressing that goes on with the number in the front, and also that a parabola opens, if it's negative, it opens down, if it's positive, it opens up. So there's a lot of things in this video that we've talked about, and if you want specific information on any one of those things that you may be confused about, please check out all those other videos that are available. This was more of an overview, and I hope it helped you out. Have a great day, everyone.